discussing about gateway redundancy protocol, router redundancy protocols, which are FHRP. First hop redundancy protocols are group of protocols which can provide gateway redundancy. So that group of protocols are HSRP, VRRP, and GLBP. So anyone quickly can tell about HSRP full form?
Host Standby Router Protocol.
Excellent. Hot, not host,
Sorry.
hot. Yeah. VRRP,
Virtual router.
virtual router. Right. Redundancy protocol. GLBP,
Global.
gateway.
Oh, sorry.
GL. G is gateway. Load balancing protocol. GLBP.
But would they still ask those? I mean, even those topics you said there are covered in
CCNP. Yeah.
CCNP, right? So would they
Yes.
still ask those full forms and CCNA certification also?
No, just I'm
Okay.
asking you.
Okay. Okay. Just
Yeah.
curious. Okay.
Yeah. So AAA stands for
Authentication
Authentication,
Authorization.
authorization, and accountability.
and account.
yeah. All right. So today I'll continue the next scenario is so have few basic fundamental questions. Try to reply everyone. There are two branches are connected, but is it really possible to connect from site one to site two directly? Like a site one is in one location, site one is another location. Is it really possible? No.
No.
So how your branch one and branch two are connected? Like you need to connect a local
Thanks.
service provider. Let's say your branch one is connected to your local ISP. Similarly, your branch two also connected to local ISP. Like all service providers are connected to internet, right? Which is public domain. Public network. Now, how branch one LAN users and branch office two LAN users can communicate? What configurations we need to do in routers to forward the traffic from one network to another network? Simple. How to enable communication one side to another side, one branch to another branch. No answer.
Configure routing table.
Simple, excellent. Configure routing protocols. That's all. That routing table can be with static or it can be dynamic. Agree? In dynamic, it can be RIP, it can be OSPF, it can be EHRP. Like any routing protocol, if you configure, then the traffic will move from one network to another network. Okay. So example, if I configured OSPF protocol, OSPF. So how OSPF works? OSPF, there are 7 states in OSPF. Down state, initial state, two-way. In two-way state, the exchanger allows. They're forming the neighbor relation. Once neighbor is successfully established, then database exchange. After database exchange, communication is possible. Agree?
Yep.
Means OSPF, first thing is it will form a neighbor. To discover the neighbor, to form the neighbor, OSPF will use mechanism called what? Hello packet mechanism. But a scenario is which two routers want to become a neighbor?
Branch one and branch two.
branch 1 and branch 2 want to become a neighbor, but branch office 1 is it directly connected to branch 2 to form a neighbor?
No.
No. Your branch 1 router is connected to your local service provider router. Your local service provider router to connect it to internet router. In internet, there are many routers are between connected. So if you configure OSP of in branch 1, then branch 1 router will send hello packet to ISP, not for branch 2. Agree?
Mm.
Then how branch 1, branch 2 can form the neighbor? So this is a very big challenge actually here. So you practically understand, guys. So there is one corporate network, one bank in one location. There is another bank in another location. They are communicating. They are all are connected. But physical setup, how it is connected, they don't have a direct links from one head office to branch office. Agree? Like one office in India, one office in UK. Like how they are connected in between many service providers. A simple example: how you and me connected, guys. Do you have a direct cable to communicate to connect the session? No. I'm connected to my local service provider router. So ISP to ISP, ISP to ISP, we are all connected to internet and we are communicating. But in between we have many devices are connected together, but still we are communicating. So now in this scenario, branch 1 and branch 2, how they become neighbors?
Set up a tunnel.
Hello packet, that is what? See, if we
Mm.
send hello packet from branch 1, it is coming to ISP. So ISP will form the neighbor. If ISP is running really OSPF protocol, then branch 1 will say hello packet to near directly connected device. Then ISP will send hello. Then ISP branch 1 will form a neighbor. That is also a big problem actually. You know why? If ISP is your neighbor, once neighbor is established, what the exchange?
Database.
ISP will maintain how much database?
Huge.
Huge database, because ISP, like many customers are connected. Like it maintain global networks, like huge database ISP will send to our router. Why we need to maintain that huge database? No need. Our router will down actually. So ISP should not be our neighbor actually. For branch 1, branch 2 want to become a neighbor. Now how it is possible? Only one option we have, that is make a direct link from branch 1 to branch 2. That is only the possible. If you make a direct link from branch 1 to branch 2, then you run OSPF. So directly we'll send the hello packet to branch 2. What do you say, Zishan? What do you say, guys?
It's not
Is it
possible.
possible? It's not
No.
possible. So that is why we connected like this. Physically it is connected to ISP, ISP to internet and like this. But now our scenario is what? It become a neighbor. This is a big challenge, right? Yes, it is possible directly connected, not physically. Virtually it is possible. So what we need to do? We need to create one virtual interface, source as serial 00, destination as branch office to serial 01, or source as branch office to serial 01, destination is serial 0/0. Like what we need to create? A virtual interface. So if we create one virtual interface, then a branch 1 in one location, branch 2 is in another location. In between, there are many routers are connected also, no problem. Branch 1, branch 2, they will feel, yes, we are directly connected. That virtual interfaces we call tunnel, tunnel interface. So tunnel is nothing but what, guys? Virtual interface. Okay. So a source has branch 1 serial port. On top of the serial port, I'm creating T1, tunnel 1. See, for serial 0/0, already ISP will provide one public IP address that is already configured here. 1.1.1.1. Let's say here also ISP will provide public IP, which is 1.1.1.2. This is normal physical setup. Now to make branch 1, branch 2 directly connected, now we are creating tunnel interfaces. Configured tunnel 1. So for this tunnel, we need to assign one private IP address. Example 10.0.0.1. In other end, tunnel number 2, 10.0.0.2. So now if you run OSPF protocol, after tunnel is configured, source as this one, destination this one. Now if you configure OSPF, now hello packet will come to ISP. Data packets ultimately should forward via physical devices only, right? But that packet will contain source is what? Yes, I am coming from so and so tunnel interface. Then ISP will understand, no, this packet is not for me. This is virtual interface. It's simply forward. Like all internet routers will forward. When it reaches to destination, then branch to serial port 1 will accept, yes, I'm your destination. I'll accept your packet. This packet is for me. I'll accept it. Then it will check the hello packet parameters, your area, my area, network ID, subnet mask, all packets are matching. Yes, you're my neighbor. Then branch 2 also will send hello packet. But hello packet is coming from which interface? Tunnel interface. ISP will check, yes, it's not for me. Like all routers will pass that hello packet. It'll come to destination is 0/0. Yes, I am your destination. I'll accept it. Okay. So virtual interfaces are created. Tunnel interfaces are created. Now you configure OSPF protocol. And OSPF protocol transaction is enabled. Communication is established. So branch 1, branch 2 will become the neighbor or not now?
Yes.
Yes. So like this, all corporate networks are connected like this actually. Physically, they are connected to service providers. Once service provider installation, connectivity, everything is done, then our network team will take care about it. Our network team, our network security team, what they'll do, they'll create a tunnel interfaces from one side to another side. If you configure tunnel interfaces, they'll be directly connected via tunnel interface. Okay. Now communication is established. But how data packets is been moving? Communication established, they're exchanging some traffic. Data packet is started, it will come to fast Ethernet to serial. On top of serial, we configure tunnel. So traffic will go to ISP to which network?
Public.
Public. So branch 1 and branch 2 exchanging the data traffic via public network. Even they're connected via public network only. So in public network, everyone connected. Then someone can capture your traffic and open that. They can be monitor what you're exchanging. So tunnel interfaces just will help only to make it directly connected, like virtual interfaces. But what about your data security? So your data should be encrypted. On tunnel interface, we need to create some algorithms. So whatever the traffic is going via tunnel interface 1, that traffic should be encrypted. We need to write that rule actually. We need to implement some algorithms. So we required what? Data encryption. I'll take one general example. Naresh, can you hear me? Sam, can you hear me?
Yeah, I can hear you.
So this is Naresh and is using WhatsApp and he also WhatsApp. Say Naresh is in Hyderabad. Say you are in US. So via WhatsApp, you are communicating, you're chatting with each other. This communication, is it private or is it public?
Public.
Private.
Public.
Private. Okay.
Public.
How public? Public means you're shouting, everyone can monitor, everyone can see?
No.
No. You connected via public network, agree, right?
Yes.
You connected via public network. But I'm asking about your communication.
Yeah, it's private.
It's private.
Is the communication is public or private?
Private.
Private.
Private. If communication is private means from Naresh device and Sham device, do you have a separate direct link you are connected?
No.
No. So Naresh is connected to your local service provider and you're getting Wi-Fi. Even Sham is also connected to local service provider and all service providers are connected to internet, which is public network. So in between there are many service providers. Now if we say like, hello Naresh, how are you? Then traffic will come to ISPs, ISP internet and WhatsApp here. So you connected via public domain, public network, but communication is what?
Private.
Private. How it's a private? Why?
Probably encrypted.
Because your entire data is end-to-end encrypted. Agree?
Yes.
So once you install WhatsApp and if you open the both, WhatsApp will create one private communication channel because your data is encrypted. Means that algorithms are inbuilt of WhatsApp application actually. Don't get confused. If data is encrypted, we can say private network, right? Private communication. Similarly, now entire branch 1 and branch 2 data is encrypted. Then what about your communication? Branch 1, branch 2 communication. Is it public communication, private communication? If data is
Private.
encrypted,
Private.
Private.
private. But how branch 1, branch 2 are connected? For branch 1, branch 2, they have a direct link. No. How they are connected?
Through
Branch
ISP.
1 connected to ISP, ISP to public network. So via public network they are connected. But communication is what?
Private.
Private. Because of data encrypted means communication is private network. So finally, how your branch 1 and branch 2 they are connected is this is a mechanism. Is that? VPN, virtual private network. VPN is a combination of tunnel plus encryption. So for every sites, for all branches, first you create tunnel interfaces and then enable encryption algorithms. So your all sites are virtually connected. Virtually connected, virtual tunnels are connected, created, right? But the base is they're connected via public network and communication is private. So VPN creates a private communication channel over the public network. Everyone we are accessing your net banking. If you see net banking, your bank server is somewhere. You are in somewhere. You're connecting to your bank server. What platform you are using to connect? The public network only, right?
Yes.
A common internet you are using, the broadband internet using, public network. But your communication is secure. Your communication is safe because VPN working direction. VPN works. Work from home you're doing. From home, you're connecting to your organization server, your corporate server through your mobile data or your local Wi-Fi. You're connected, your public network, but you're connecting to your corporate office. Like how it's possible. VPN works there actually. So VPN creates a private communication channel over which network?
Public network.
Public. That's a simple, excellent point actually. If someone is asked about VPN, VPN creates a private communication channel. Means a secured, encrypted, private communication link channel over a public network. That's all. It provides a private communication channel over a public network, provides security because your data is encrypted. Point-to-point connectivity provides tunnel. Tunnel is created. One point to another point. Scalability. So VPN is compatible to create for any type of networks. It's not like a recommended for small or medium, like not like that. It can be compatible for any networks. We can create VPN for small, medium, large enterprises, any type of. Got it? So VPN provides the features of VPN is confidentiality, data encrypted, privacy. Data is confidential. If someone is captured, if they open that, the data is encrypted actually. Authentication. If you want to open that packet, they require authentication, password required. So this is a data packet, guys. This data packet, when comes to branch 1 and branch 1 router, what you configured? You configured VPN. So what VPN can provide? Confidentiality. Next thing is what? Authentication. Means this data packet is password protected. Keys are configured. And the entire data is what? Confidentiality means encrypted. So password protected and data is encrypted both. Now data will go to ISP to public network. Now someone is trying to capture. They captured actually. And then trying to open that packet. To open that packet, what that packet will ask?
Password.
Password. Yeah, you want to open? Yes, give me password, I'll open. Then what is the hacker task now? Crack the password. So he implemented some random passwords, combination of passwords. He runs some script actually. Fine. After some time, he break the password. He cracked the password. After open the password, then again data is what?
Encrypted.
Encrypted.
Encrypted. See how much level it is secured. In first case, password protected. Next case, data is encrypted. And one more thing is data integrity. Data integrity. See, what hacker can do is, hacker, he don't know password. First case is what? He don't know password, right? And second case, data encrypted. Then what hacker can do? Okay, why we need to crack the password? I will do one thing. I will remove some data packet. I'll remove some data. If you remove some data, now your destination can be understood properly. Or a hacker can inject some false information. And that false information like branch to, oh, it is really okay. Oh, something. So it's deviating the traffic action. That can be possible. So instead of open the password, open the packet, and what is inside, seeing that, what hacker can do? Ultimately, hacker motive is what? To disturb the network actually. So he can be add some data, false information, or can remove this information. I'll ask you one general question. You order some in online, in Amazon somewhere, you have ordered some product. The product is delivered. But the product is, it is sealed, opened. The package is broken actually. Do you accept that?
No.
Why?
It's a broken condition.
So what? How we can trust if it's opened already? So something is being missed or something is added someone, right? We don't know what is exactly happened. Yes? Same. If you are trying to modify something data here, adding something or remove something, if any is modified, VPN can support for what? Data integrity means the destination which is branch to, no, I'll not accept this packet, I'm dropping it because it is modified something actually. So VPN can support data integrity. The modified data cannot be accepted, it is dropping it. No, I'll not trust it. Drop it. So what are the possibility chances are there? No hacker, what can do? He's trying to crack the password, or he's trying to decrypt the data, or he's trying to adding something or removing something. Everything is secured. Your VPN support for that all. Data confidentiality, authentication, data integrity, and anti-replay also. So if packet is already replied, so second time it won't be reply action. Okay, that's something you can understand in cyber security sessions clearly, like how it anti-reply. So we need to packet level, we need to analyze. So something typical we'll see in the cyber security sessions. So these all are the features of VPN. Now let's understand types of VPN. In types of VPN, basically Cisco developed one VPN called GRE VPN. DM VPN. IPsec VPN. All are different type of VPNs actually. GRE VPN, it is developed and it can support only
Just
to
go.
create tunnels. GRE VPN can support only for what? Tunnel, virtual
Tunnel.
interfaces between branch 1, branch 2. And that tunnel also, it can support only one point to another point. But this GRE, no encryption mechanism, only tunnels. Whereas DMVPN, dynamic multi-point VPN also, it can support for creating tunnels without no encryption algorithms. But good thing is it can support from one point to multi-point. From one point, it can make multiple tunnel interfaces. One point to multi-point. But what we require finally, we require to create tunnel as well as what? Encryption also. That can be possible with IPsec, Internet Protocol Security. It can support to create tunnel interfaces and it can support an encryption, very strong encryption algorithms it can support. Okay. GRE, IPsec VPN, SSL VPN, Secure Socket Layer, DMVPN. This SSL VPN, all applications, web applications are created with SSL VPN. Like your web browser, through web browser you're accessing all website, right? So this web browser is inbuilt with which one? SSL VPN. Connection is what? Secure. See, if Chrome trusts this certificate and Chrome has private connection with the site, it's a private connection. Private connection means what?
Secure.
Encrypted, secure. Yeah. So this Chrome is configured with SSL VPN. Okay. But your corporate routers, firewalls, those routers are configured with IPsec VPN, GRE VPN, DM VPN, those actually. Yeah. Even your mobile applications, all mobile applications are configured, created with SSL VPN. GRE VPN, generic routing encapsulation, GRE. GRE is a tunneling protocol that was originally developed by Cisco. But good thing in GRE is GRE provides tunneling for non-IP traffic calls. Basically, only IP traffic can support, but GRE can support IP and non-IP traffic calls. So which is not done by IPsec. IPsec will done only for IP. But GRE can provide non-IP, which is IPX, AppleTalk, also. Anyhow, GRE provides only what? Tunneling without any encryption. So GRE is recommended to go static routing to configure towards the relevant LAN. Like an example we done with OSPF between the site 1, site 2. Here we need to configure static routing. Hello. Yes. So let's see configuration part, how to create these tunnels and how to activate the tunnel. Interface, tunnel number. A number can be any number. Yeah. See, R1, R2, they're connected via service provider network with serial interface 0/0/0. Other end, serial 0/0/1. Initially, ISP will provide one public IP address. So it is 1.1.1.1. In other end, 1.1.1.2. On top of this physical connectivity, we need to create tunnel interfaces. Tunnel 1, tunnel 2, and these tunnel interfaces we need to consign private IP address. This is interface tunnel 1, IP space address, private IP address. That's something we can decide. My example 10.0.0.1. But in other end, both ends should be in same network. 10.0.0.1 here, 10.0.0.2. Okay. See the commands, interface, tunnel 1, IP address 10.0.0.0.1, 255.0.0.0. Tunnel source. What is the tunnel source? Where we created tunnel source is serial interface 0/0/0. Here's the source, right? And what will be tunnel destination? Is tunnel 1. Destination is not R2 serial port. So destination should be your unique public IP address. Router 2 public IP. What is that? 1.1.1.2. Now tell me in router 2 configurations. Interface, tunnel number 2, IP address 10.0.0.2, 255.0.0.0. Tunnel source Source is your serial interface, which is 0/0/1. Tunnel destination
One
for
dot.
R2, yes, 1.1.1.1. Then your tunnel will be up. So R1, R2 router will communicate via tunnel interfaces. Even in between, there are many service providers routers are also connected, but R1, R2 are directly connected via tunnel interface. Okay. This is R1 config mode. Interface tunnel 1 IP address 10.0.0.1 tunnel source serial 0/0/0 tunnel destination 1.1.2. Done. In router 2 also. This is router 2. Interface tunnel 2 10.0.0.0.2 255.0.0 tunnel source is 1.1.2. Sorry, source is serial 0/0/1. Destination is public IP. One dot one dot one. Show IP interface brief. Tunnel 2. Status is up. Now we can reach out via tunnel interface. If you ping from R2 to tunnel IP, you can reachable. Got it? So this is how we can understand about how VPN, GRE VPN works. Hello? Okay. More doubts?
Where are we defining to reach to the destination? I'm like how the routing will be configured on this tunnel interface?
Static routing need to configure.
Okay.
To reach to tunnel destination, we need to configure static routing. That is what this note you can see. Static route should be configured towards remote LAN network via tunnel interface.
So it will be a common routing table, right? It is not something different for this tunnel.
Normal, common, yes. Normal routing table. Just we need tunnel interface how to reach that routing information. Yeah.
Okay.
More doubts?
There's no encryption, right?
For encryption, we need to configure IPsec.
IPsec. So it's a little bit complicated. Like,
Yeah, first you need to understand this how this algorithm works, how encryption works, how data is being exchanging between the site. So IPsec will generate some keys actually. Private keys, public keys, how they're exchanging, how it's secured. These all the stuff we need to understand. So in cybersecurity classes, we'll get to know about it, how they exchange as a public keys and private keys and all.
mm,
Yeah. Okay. Says your organization router, and as an engineer, you're trying to connect this router. So you connected console cable to console port, and you open putty. You're trying to connect router. So router is asking password. If you know password, you can enter. If you don't know password, what will do? So via console port, is this password protected, password secure, but you don't know password, then even you tried via LAN port, telnet, they're asking password, but if you don't know passwords. So basically, the concept is like if you don't know passwords, then how to revert it actually. If you don't know passwords means are you hacker? What? No, it's not like that actually. You are a network engineer for branch A. So you're managing all sites, branch A sites. Branch A devices, you have credentials for all branch A. But after some time, some devices came from branch B. Those devices, you don't know what credentials, what passwords are they set. Now we need to uh, reset all configurations and you want to use it for branch A. Then how to work? So this type of scenarios. Concept is what? Password recovery. Can recover the password. So how to recover the password is very simple concept. Please understand. First, we need to understand about router boot process. A Cisco routers boot process, boot sequence. When you power on router, first is post, power on self test. Once this process is done, the next sequence is it will come to ROM. In post, in power on self test, it will check all hardware parts. In ROM, it searches for IOS. Where IOS will present? In flash memory. So it is loaded from flash memory. Once iOS is loaded, it will come to configuration, where all configurations will be stored. NVRAM means in NVRAM, your device IP addresses, device password, all configurations part permanently stored in NVRAM. So router is asking for this configuration action. Once you entered password, then a running configuration will come, which is RAM. This is boot sequence. Host, ROM, flash, NVRAM, and RAM. How every router will boot the same process in the same sequence order, how device will process. So every device is pre-configured with a register value. If we check show version command in the last line, can get configuration register is 0x2102, which is a default register value for all type of Cisco devices. 2800 series, 2900 series, no branch router, other network edge routers, any model numbers, a default configuration register value is 0x2102. So because of 0x2102, boot sequence will come like this: host, ROM, flash, NVRAM, and RAM. Example, I'm trying to log into router 3. See, router 3 is asking password. Basically, what password we use? We configured CCNA, Zoom, Cisco. I tried our all regular combinations. Does not work out. So something, password is something we don't know. So what is the boot sequence for this router also? Even for this router also, default configuration register value is 0x2102. Every Cisco router default is 0x2102. Then post, ROM, flash, NVRAM. So whenever NVRAM will come in the boot process, it will ask password, but we don't know password. Then what we need to do? Nothing is, we can configure that router you boot like this. How? Post, ROM, flash, skip NVRAM, and come to RAM. If we skip NVRAM in boot process, passwords will not ask. Without passwords, we can log into the router. Simple. So if we don't know passwords or if we forget the password, what we need to do? Skip NVRAM in boot process. That's all. The question is how to skip NVRAM in boot process. So what is the default boot process? Post, ROM, flash, NVRAM, and ROM. Because of which value? 0x2102. That register value will to change as 0x2142 to skip NVRAM to change register value is 0x2142. Yeah, 0x2142. If we change the register value, this register value is going to skipping NVRAM and boot process. Once you skip NVRAM without no passwords. But how to change the register value? I'll give the proper steps. Password recovery steps. Step 1, connect console cable from router console port to your PC. Connect console cable directly to your router to your PC, your laptop, and open the software. This PuTTY software. Next step, restart the router, like power off and power on. After restarting, press Control break key on your keyboard. On your keyboard, you can see break key. Control break to enter into Roman mode. In Roman mode, you can change register value. I'll tell you one thing for easy to understand. You want to change your BIOS setup. in BIOS settings for your computers. Want to change some BIOS settings. Tell me what is the procedure?
When we restart the PC, we have to keep hitting delete button.
Okay, after restarting PC, after 2 minutes, if you press the delete button, it will come to BIOS settings?
No, no.
No. So first step is what? Restart your machine. And then immediately you keep hitting this Dell or F10 or F12, depends upon the OS, right? Models. Then you'll get what screen? BIOS settings, blue screen. There you can change the settings, right? Most similarly for routers, same procedure. A Roman mode. Roman mode is similar to BIOS of your PC actually. How to get Roman mode? Restart router and press Control break key within 30 seconds. And then you can get into Roman mode. In Roman mode, you can change register value. How to change the register value? This is Roman mode will look like this. Rom monitor greater than symbol. You can use this command. Confreg, C-O-N-F-R-E-G. Confreg means configuration register. Space 0x2142. The next line, reset. So again, router logically to reboot and we'll check what is the latest register value. Oh, register value now it is 42. It will skip NVRAM and get into routers without any passwords. Let me do it now. See, router 3 we don't know passwords. Going to physical, power off, power on, press Control break key. So it is Roman mode. So here you can change register value as config 0x2142 0x2142 reset. Continue with configuration dialog. Now, see, I'm in router user mode. Enable. So to recover your password exactly, you can use this command show startup-config because all configurations will be stored in startup config. Enter. Yeah. So what is enable password? Enable password is password at 2022 with special characters. Console password is webcast at Zoom Technology. Telnet password is Cisco at 2022. So we can recover the password exact. Once you record the password, then we can revert it back. I mean, we need to change the configuration register value as default configuration register value. If we check show version command, showing 0x2142 now. So set it to 0x2102, which is default register value. After record the passwords. Or you can create a new passwords also now. In two options. Config register 0x2102. In global configuration mode, you can use this command config-register 0x2102. But this register value will take effect after the next reload actually. So every time, whenever you change the register value, your router should be reload. So even if you check show version command, still it is 0x2142 only. When it will be 02 at next reload. So if you reload your device, then a new configuration register value will take effect. So this is a simple method you can recover the password from Cisco routers. Clear? Any doubts?
Could you show me that command, show config and
Show running config.
show running config?
If you give the show running config, running will be empty, which is RAM. All configurations will be present in startup config, which is NVRAM. So to get the passwords exactly, you can use this command actually. Show startup -config.
So this is not using the PuTTY software, right?
You can use all commands can execute.
Okay, okay.
In PuTTY software only, after changing register value, if you reboot, right, it lasts the dialog. Would you like to continue configuration dialog? You can see type no. I'll come to user mode and come to privilege mode. There you can see, you can get, you can use this show startup config command. Then you can see exactly what are the passwords are configured.
Okay.
Or you can do one thing, directly you can create new passwords also. Clear?
No.
Yeah. Any more doubts? See, I have assigned IP address for server, which is 192.168.2.123. The concept is how to take a backup files. Means configuration backup or IOS backup. These both files are very important files, right? If something went wrong, if your IOS file is corrupted, then your device will be down. So better you maintain one file, backup file. If something wrong, it is down, then immediately you can reload it, restore it, and you can make your your router is active. And configuration backup also. If you take a configuration backup, see this, whatever the configuration in R1 router, all plans, all configurations, this configuration, same configuration you want to configure R2, R3, R4, like R50 routers are there. So just take a backup from this router, notepad file, copy paste in all routers. So this backup will help us for different purpose. If you take a backup file, then your NVRAM is down, NVRAM file corrupted. You want to install the new NVRAM. Then using this backup file, you can restore all the configurations. If you have a backup file, like after few months or years, like what configurations we was using earlier, want to recheck, you can check this. So backups are very important actually. To take the configuration and IO's backup, we need one server. I mean, just a computer also enough actually. Say your computer. In your device, you must install TFTP application. This is TFTP D64 32, depends upon the operating system processor, 32-bit processor 64. So TFTPD, this free application you can easily download from internet. Here we have TFTP server, syslog, DHCP server. So you can see the logs also here, syslog logs information. It will collect all the logs information. But now what we need to do, we need to take a backup files. Point is router LAN interface IP and TFTP IP should be in same network. It is 2.1 and TFTP server IP. What IP I have assigned in packet tracer software example 2.123. Both are in same network. That's enough. Now you can take a backup. What file backup you are taking now? What files? Flash backup and configuration. Where your configuration will store permanently? Startup configuration. So backup means what is? A copy of original. You're taking one copy from original files. So flash is our original. This copy you're taking to and store to destination, which is TFTP. So same command, copy flash is the source. Where to store TFTP is the destination. Simple command. Copy flash TFTP. Then what is the command to take startup configuration backup? Copy startup config space TFTP. Simple. So this copy command on privileged mode can do in privileged. Let us do it. In privileged mode, before that, we'll go to server services TFTP. TFTP. See, I already have many IOX files are listed. I'm removing these all files. Yeah. Now we don't have any backup files. So log into router, enable, copy startup -config TFTP. It is asking TFTP server IP address of the server, address or name of the remote host. What is server IP? 2.123. Destination file name. So this startup config file has to be saved in your server by on which name is asking the destination file name. You can configure something, or if you don't configure, it will store as default R2 config. Let be default names. Done. Now you can see backup file in TFTP server. See, this is R2 config. Okay. Next, flash backup. Case copy flash command. Sorry. Show flash command. Then you can see the extension .bin files. .bin file is a flash. So from Cisco 28, this is iOS file name. Just right click, select right click, copy. Now can use copy command. Copy flash TFTP. Source file name. Whatever you copied there, you select right click, paste. Server IP address 2.123. Destination file name. Let be the same file name. Done. In TFTP server, you can see two files. R2 config, flash config, flash file. It's clear? Like this, we can take backup files. Any more doubts? All right. So it's all about for today. And tomorrow we'll continue with our last session. We'll see some router commands and some wireless concepts. Thank you. Have a good day.
Thank you, sir.
Thank you.
Thank you all.
Thank you, sir.
Thank you, sir. Hello, sir.
Yeah, Bhargav.
Sir, if possible, can you please share previous like all the commands from like files before you have shared like that?
I don't have any no all practical, but few commands I have, I'll share it in the WhatsApp, okay?
Please,
Whatever
sir,
the
please.
commands I have, I'll share it. Yeah.
That will be very helpful for us. Thank you. Thank you.
Okay.